Okay, so for number one, the way that I'm going to solve this one is I'm going to change them into sines and cosines. So what I'm going to do is I'm going to change cosecant into its reciprocal, which is 1 over sine. So I'm going to change cosecant, and I'm going to make it 1 over sine x minus sine x. And I'll put a 1 underneath, because now what I want to do is find a common denominator. My common denominator is going to be sine. So the only fraction I need to change is the second one. So I'm going to multiply the top and the bottom by sine x to turn it in to have a common denominator. So this will become sine squared x over sine x. Next thing I'm going to do is add my numerators. So I'm going to get 1 minus sine squared x over sine x. I know that I can replace the numerator with an identity, because I know that sine squared x plus cosine squared x equals 1. So I'm going to change this, and I'm going to make my numerator now cosine squared x. I still have the sine x in the bottom. I told you not to touch the other side, so we can do two things here. I could keep working with this side, and if I keep working with this side, I'm going to change the numerator into cosine x times cosine x. And then the denominator, and actually I'll split it. Then the denominator, I'm going to just put a 1 times sine x. And now this will simplify individually. This becomes cosine. And then this one becomes cotangent. Now, if pulling it apart confuses you, what you could have also done is at this point right here, you could have said, okay, I'm going to stop here at cosine squared x over sine x. Then take this, cosine x, cotangent x, and simplify that. And make this equals cosine x, and then change this to cosine x over sine x. And then when you multiply this one now turns into cosine squared x over sine x, which is what that equaled. So either way, if you want to touch the other side a little bit so it makes it equal the other side, you can. Okay, but I would not try to go through and simplify both of them. It'll get too difficult. Try to touch the other side minimally. All right, let's try the other one. Now, the answer I posted for number 2, I actually changed it into sines and cosines. But then someone in my A period class said, well, I just found a common denominator. Another person also changed cotangent into 1 over tangent. And I posted that online, or I'm going to post it on Canvas. I'm going to show you the way that they showed me in A period, and I'm going to find a common denominator. And my common denominator is going to be tan x times cotangent x. I'm going to write that at the bottom of both. Let me do this denominator in another color. Do this one in blue. So tan x, cotangent x, and then it's got a plus sign. So this fraction over here is missing the cotangent. And then this one's missing tangent. Now I'm going to add my numerators. So this becomes cotangent x plus tangent x, and then it's over the common denominator. And if you realize when you multiply tangent x times cotangent x, these are reciprocals. So if I change cotangent into 1 over tangent and multiply it by tangent, what remains, this equals 1. Yes? So now this is going to become a 1. So then I get cotangent x plus tangent x, And like Sophie said, it's commutative, so I can flip it around. And now that equals what I was trying to set it to equal. Tangent x plus cotangent x. The file I'm going to post has two other ways to do it. One of the ways is more complicated. So again, there's different ways to do these. And that's why when you did the homework, there weren't answers in your textbook, because there's not one set way to verify these identities. All right, the next one, what I posted on Canvas was multiplying by the conjugate. I'm going to show you a simpler way to do it by just changing secant into cosine. So I'm going to change the secant that's right here, and I'm going to make this 1 over cosine minus 1. That's my numerator. And then my denominator, just going to rewrite it, 1 minus cosine x. For my numerator, I need to find a common denominator. So if I put a 1 here, my common denominator is going to be cosine. So multiply top and bottom here by cosine. So then my new numerator is going to be 1 minus cosine over cosine, and then divided by 1 minus cosine x. I'm going to do a keep flip change. So I'm going to keep the blue, and then I'm going to divide by the red. So when you divide fractions, you flip it to the reciprocal. So I'm dividing by 1 over 1 minus cosine x. Those will cancel. I'm left with 1 over cosine x, which equals secant, which is what I was trying to make it equal. Secant x equals secant x. It verifies. Let's take a look at number 4. So what I'm going to do is I'm going to work with the left side, and I am going to change my tangent into sines and cosines. So I'm going to rewrite cosine. Oops. So cosine x minus, and now I'm going to work with this. So I have cosine x. I'm going to change tangent into sine over cosine. I'm now going to find a common denominator of the denominator. So let me rewrite the black, leaving the red alone. And now I'm going to work with the denominator. I am going to find a common denominator, which is cosine. So this will become cosine x minus sine x over cosine x. Now I'm going to do a keep flip change just of that one term. So what I'm going to do here is I'm going to divide this. So let me see if I can go over here. Let's do it here. So cosine x divided by, or times by the reciprocal. Let me keep this in red. I'm going to flip the blue upside down.
What does it say above 1? No, the one you just wrote.
Oh, cosine x.
Okay.
All right. So this green is what I'm dividing here. So now, once I multiply this, this becomes cosine squared x over cosine x minus sine x. So now let me take all of this and put it up top here. So I have cosine x, this original black thing, and then minus cosine squared x over cosine x minus sine x. I'm now going to find a common denominator again. My common denominator is going to be cosine x minus sine x. So cosine x minus sine x. Cosine x minus sine x. So when I distribute the cosine to both of these, I get cosine squared x minus sine x cosine x over cosine x minus sine x, and then over here, this fraction here, just rewrite it. So now I can add my numerators. So notice when I add the numerators, these cosines cancel. So now I'm left with negative sine x cosine x over cosine x minus sine x. Notice it looks very similar to what I was asked to find. My signs are just off. So I'm just going to multiply the top and the bottom by -1, and that switches my signs. So sine x cosine x positive. If I multiply this by -1 and this, it flips the signs. So now I'm just going to flip it around and write the positive first and the negative second. And it verifies. Number 5, remember the cube pattern is this. A cubed minus b cubed is a minus b, same sign, square the a, multiply the a and the b. This is opposite sign, and then always positive. If this were starting out as a plus sign, again, the signs are the only thing that change. So I got a tangent cubed x. So I cube root tangent cubed x. That gives me tangent x. Cube root 1 gives me 1. And then in here, this part of the pattern, tangent squared x plus tangent x plus 1. And it still has the original denominator, which is tan x minus 1. This cancels, and there's my answer of what I was trying to verify. So that one, all you needed to do was factor it. Okay, so for this one, I'm going to find a common denominator. My common denominator is going to be 1 minus cosine x and 1 plus cosine x. So this first fraction is missing the 1 plus cosine x. So my new numerator here is 1 plus cosine x, and I'm just going to write it as squared for now. If you want to write it 2 times, you can, because we're going to have to FOIL it. Over here, this one's missing 1 minus cosine x. So 1 minus cosine x, 1 plus cosine x. It's got a minus sign in here. And then the new numerator is 1 minus cosine x squared. All right, so now I need to FOIL my numerator. So the blue one, when I FOIL it, I end up with 1 plus 2 cosine x plus cosine squared x. And then over here, this one gives me, I got a minus sign here, and just, so I got to distribute the subtraction sign. So after I FOIL this, I'm going to put this in parentheses, and then plus cosine squared x. So this subtraction sign, let me FOIL the denominator too. This is multiplying by its conjugate, so really all I need to do is first and last. So 1 minus cosine squared x. Now, for the numerator, this subtraction sign needs to distribute. So let me rewrite the first. 1 plus 2 cosine x plus cosine squared x. Then I'm going to distribute the sign, so it becomes a -1, then plus 2 cosine x minus cosine squared x. And I'm going to change the denominator to a sine squared x. That's an identity. I'm going to combine my like terms in the numerator. 1 minus 1 is 0. Cosine squared minus cosine squared is 0. So the only thing I'm left with in my numerator now is 2 plus 2 is 4 cosine x, and then it has sine squared x in the bottom. Now, what I need to realize that I could split this apart, and I could change the 4 and put a sign underneath, and not a square, just a sign. And then take the cosine and put a sign underneath it. Because think about it, if you multiply these two fractions, it goes back to this. So then now this becomes 4 cosecant, and this becomes cotangent. I can flip it around because it's commutative. So then I'm trying to make it equal 4 cotangent x, cosecant x. It verifies. Number 7 is just an identity. So I'm going to change my numerator. The 1 minus sine squared x. I'm going to change this into cosine squared x. So it becomes cosine squared x over cosine. I can simplify the cosines, and it equals cosine, which is what I was trying to make it equal. For number 8, all I'm going to do is, this is an identity here, so I'm going to change that to secant. So I'm going to write cosine squared x, and then I change tangent squared x plus 1 to secant squared x. I'm trying to make it equal 1. Remember, whenever you multiply something by its reciprocal, this equals 1. But if you need to see it, I'm going to change secant into 1 over cosine squared x. And again, whenever you multiply by its reciprocal, you get 1. 1 equals 1. It verifies. And for the last one, I'm going to multiply the right side by its conjugate. So I'm going to multiply top and bottom by secant x plus 1, secant x plus 1. I'm going to distribute the cosine to both. So this will give me cosine x times secant x plus cosine x. Remember, when you multiply something by its conjugate, you just have to do first and last. So secant squared x minus 1. That is an identity. So I can change this to tangent squared. So now I have, and then the top part, cosecant x times the reciprocal of secant, which is cosecant. This also becomes a 1. And I have my new bottom, which is tangent x, tangent squared x. So this cancels, and I get 1 plus cosine x over tangent squared x, which is what I was trying to make it equal.